Okay, hello again. This is the questions and answers on organic chemistry. So let's take a look at the first question. The first question says, draw the structural formula of each of the following. Show all the bonds. So remember, when he says show all the bonds, you have to show all the bonds between the atoms. So we want to draw ethanoic acid. The first thing you ask yourself, eth is how many carbons? 2 carbons. Oic acid means it must have C double bond O, single bond OH. So that is the acid part. And then you complete the structure so that each carbon must have a total of 4 bonds. So that first carbon needs 3 hydrogens in addition to the bond to the carbon. And that carbon already has double bond O, single bond OH, so you don't put any hydrogens on it. So that is ethanoic acid. Ethanol, again, 2 carbons, and all must have an OH, and you complete the molecule so that each carbon has a total of 4 bonds. Can you see the structure of ethanol? Okay, the next question says, state 3 characteristics of a homologous series other than variation of physical properties down the series. So we said members of the same homologous series must have the same what? They must have the same general formula, same functional group, same chemical properties. Do we understand that? These are the 3 characteristics of the members of a homologous series. What does each of the following tell you about the structure of something called dibromoethane? So the word dibromo, you should know that di means 2. Bromo means 2 bromine atoms. Now we said the word eth, or the part eth, means what? It means 2 carbon atoms. And ane means it's an alkane, so that means it has only single bonds between the carbons, no double bond. Okay, the following alcohols are isomers. Explain why they are isomers. What was the meaning of isomers? We said isomers are compounds having the same molecular formula but different structures. So that is what applies to these 2 molecules. Both of them have 4 carbons and the same number of hydrogens and the same number of oxygens, but they have different structures. Now he's saying draw the structural formula of another isomer. Now this is an alcohol that has how many carbons? 4 carbons, but he has the OH on the last carbon, right? So we said if we have the OH on one end, then the other isomer will have the OH somewhere in the middle. So that would be the isomer of that compound, which is butanol. Okay, the following hydrocarbons are isomers. Again, give the structural formula of another hydrocarbon, which is isomeric. Now these are alkenes. So the double bond here is on one end, and we said if we want to draw an isomer, then instead of putting the double bond on one end, I can put the double bond in the middle. So that is the isomer. Okay, the structure formula of cyclohexane is drawn. The name gives information about the structure of the compound. We said hex means it has 6 carbon atoms. The word cyclo means that these 6 carbon atoms, instead of just being in a chain, the chain is joined together to form a ring. So what information about the structure of this compound is given by the ending ane? We said if something is ane, that means it is saturated or contains only C single bond C, or it doesn't have any C double bond C. Now what are the molecular and empirical formula of cyclohexane? Remember from the chapter on chemical calculations that we did, we said molecular formula means you count all the carbons, all the hydrogens. So how many carbons do we have here? We have 6 carbons, 12 hydrogens. So that would be the molecular formula. But the word empirical formula means the simplest ratio between the atoms. So this 6 and 12, we need to simplify it. How do you simplify something? Usually by dividing by the smallest. So the simplest formula of this would be CH2. I divided through by 6. Okay. Draw the structural formula of cyclobutane. Now he had drawn for you cyclohexane. So if we want to draw cyclobutane, you're going to ask yourself, but means how many carbons? 4. So you're trying to draw something that is cyclic with 4 carbons, and then you complete it so that each carbon has a total of 4 bonds. Deduce the molecular formula of hexene. Remember we said ene is alkene, and what was the general formula of alkenes? We said alkenes had a general formula of CnH2n. We said the number of hydrogens has to be twice the number of carbons. If he told you already that hex means I have 6 carbons, that means the number of hydrogens would be 12. Okay? Explain why cyclohexane and the alkene hexene are isomers. Remember that what we just found for the cyclohexane was that its formula is C6H12. Well, hexene also has a formula C6H12, and that means they are isomers because they have the same molecular formula but different structures. Okay? Now, butane, an alkane, reacts with chlorine. Remember that we said when alkanes react with halogens, now what type of reaction was this? This was a substitution reaction. And we said when we do alkanes with halogen, you remove one of the hydrogens and you put a chlorine, one chlorine. So the organic compound which contains the halogen, chlorobromoiodo, the following diagram shows the structure of one chloropropane. So he has propane, that means 3 carbons. 1 chloro means the chlorine is on the first carbon, and we said the first carbon could be either from one end or from the other. That's the first carbon. Okay, draw the structure of an isomer. We said if I have something on one end, then the isomer would have that same thing in the middle. So instead of putting the chlorine on one end, we're going to put the chlorine in the middle. So that would be the isomer. Okay, describe how 1 chloropropane could be made from propane. Again, if I start with propane and I want to make 1 chloropropane, then I'm reacting the alkane with chlorine. So we're reacting the propane with chlorine, and remember that this is the substitution reaction and the condition was UV light. So reaction of chlorine in presence of UV light. So just an explanation why the method you have described does not produce a pure sample of 1 chloropropane. Remember, when we said we have propane and we have chlorine, and this, what happens is the one chlorine will replace one of the hydrogens. Well, in the one he gave you, so let's go back, the one he gave you here was the fact that it had 1 chloropropane. Well, we said it could remove any of the hydrogens. So actually I will not have just 1 chloro, I could have the 1 chloro and the one with the chlorine in the middle. So that is the 2 chloro. So in addition to that, we said when we do this, one of the reasons would be because I'm not just going to get 1 chloro, I could get 1 chloro and 2 chloro, and the fact that when we remove 1 hydrogen and replace it with chlorine, then the other product would be the hydrogen with the other chlorine, so it produces HCl as a side product. So I don't just get a pure product, I don't get only 1 chloropropane. Following? Okay, the next question says, the alkenes are a series of unsaturated hydrocarbons. They have general molecular formula CnH2n. Deduce the molecular formula of an alkene, which has a molecular mass of 126. So I want something that's an alkene. Alkene means the number of hydrogens should be twice the number of carbons. And we want the total to be 126. So how do you do that? I can do it with a math problem and solve for x. So I have carbon has a mass of 12. So I don't know how many carbons I have. So I'm going to say 12x plus the hydrogen. If the carbon is x, then the hydrogen will be 2x, and you know that hydrogen has a molecular mass of 1, so that is 1 times 2x, and we're saying the total is 126, and you can solve for x. So that actually means that x should be 9, and that means that the formula of the alkene should be C9H18. If you sit down and calculate it, you'll find that the total molecular mass is 126. Okay, explain the term hydrocarbon. What was the meaning of hydrocarbon? We said hydrocarbon means it contains carbon and hydrogen only, the word only. If it is missing, you don't get the grade. What is the difference between these two series of hydrocarbons? So he was talking about alkenes and alkanes. What is the difference between them? That alkanes have only C, single bond C, so we call them saturated. Alkanes, have only C, single bond C, so we call them saturated. And alkenes have a double bond between the carbons, and that is called unsaturated. Okay. So this is the next one. It says complete the following equation for cracking. Remember we said what is cracking? Cracking is the breakdown of a long chain hydrocarbon into shorter chains. So if I'm starting with C20H42, I'm going to break it up so that the total number of carbons and hydrogens are 20 for carbon and 42 for hydrogens. So let us take them one by one. On one side, before the arrow, I have 20 carbons. So after the arrow, I should have a total of 20 carbons. So that is 2 times 4. That's 8. 8 plus 4 is 12. So from the 20, I am left with 8. The hydrogens, 2 times 8 is 16. Plus 2 times 4 is 8. 16 plus 8 is what? 24. And I subtract that from the 42, I end up with 18. So the rest is C8H18. Okay? So that's just the rest of the 20 carbons and the rest of the 42 hydrogens. Okay, explain the phrase substitution. We said substitution means a reaction in which a halogen replaces one of the hydrogen atoms in alkanes. Okay? How do photochemical reactions differ from other reactions? Oh, he was talking about photochemical. Remember that a photochemical reaction is one that requires light to make it faster. Okay, a photochemical reaction is one that requires light to make it faster. Okay, now he's talking about, give the structure, formula, and name of each of the products of the following addition reactions. So here we're talking about reactions of alkenes with something. Remember that we said when alkenes react, they do addition. So alkanes do substitution. We replace one of the hydrogens with a halogen. Alkenes do addition. And we said when we have addition, so he's saying, for example, we have ethene. Okay, this is ethene. Now he wants to react it with what? With bromine. Now what should this give me? We said when we have an alkene and it is reacting, I copy it, but instead of the double bond, I put a single bond. And then I put something on each of the carbons that had the double bond. So if I'm reacting it with bromine, then I should put a Br and a Br. So this is my compound that should be formed. Now what would be the name of this compound? Remember that the first thing you think about, how many carbons? I have 2, so the name must have eth somewhere. And then, is it alkane, alkene, alcohol, acid? Well, it has only single bonds between the carbons, so it is an alkane. But then it has 2 bromines. So how do I denote that? I have 2 bromines, that means I have dibromo. Now, on which carbons are the bromines? Well, the bromine, one of them is on carbon number 1, the other one is on carbon number 2. So this is called 1,2-dibromoethane. Do we understand that? Okay, let's try the next one. He says propene and hydrogen. Now, what is propene? Propene is an alkene that has 3 carbons. Okay, he wants to react that with hydrogen. So what should this give me? Well, we said again, the double bond should open up and become a single, and I should put something on each of the carbons that had the double bond. Now, I'm reacting it with hydrogen. That means I will put an H and an H. So that is my product. Okay, how do I name this? Again, how many carbons? 3. So the name must be prop something. Now, which kind of compound is it? Well, it has only single bond, then it is an alkane. So this is propane. Were you able to do that? Okay, let's try this again. But1-ene, we said but1-ene. But is something that has 4 carbons. 1-ene means it has a double bond between carbons. Now, where is the double bond? If it says but1-ene, that means the double bond is after carbon number 1. Again, carbon number 1 could be on one end or it could be on the other. So what is drawn there is but1-ene. And we're reacting it with water. So We said when this happens, what do? We open the double bond, we put it as a single bond, and then we add something to each of the carbons. Now if I'm reacting it with water, we said I'm going to add hydrogen to one of the carbons and OH to the other carbon, so I am forming an alcohol, which is 1-butanol if it is drawn as it is drawn there. If I put the OH on the second carbon, then the name would be 2-butanol. Okay, how is butanol made from butene? Again, this is the same question. I have butene and I want to make butanol. So this is butanol. Butanol means something that has an OH somewhere. That means I opened up the double bond and added water, and that means we add water. And we said, what are the conditions for adding water? Remember that we had conditions for adding water. I need phosphoric acid catalyst and 300 degree centigrade. Okay, so he says include an equation in your answer, so I have to put an equation. So butene is C4H8. I'm reacting it with water, and this is how we write the alcohol. We count the number of carbons and the number of hydrogens and put the OH at the end. Okay, so this is C4H9OH. Or you could also write it as C4H10O, but this is how we usually write it. Cracking changes alkanes into alkenes. How could an alkene be converted into an alkane? So here I'm starting with alkene, which has a double bond somewhere, and I want to change it to alkane. Alkene, for example, like butene. Now I want to change it to alkane. This is an alkane. That means I added what? Can you see that I added 2 hydrogens instead of the double bond? So changing alkenes to alkanes, I should add hydrogen. He wants an equation, so this would be the equation that we have. Okay? Describe how ethanol is made from petroleum. Remember that we said petroleum is the raw material for all organic compounds. So if I'm starting with petroleum, how do I end up with ethanol? You should remember that petroleum, we do fractional distillation of petroleum. Then we do what comes out from the petroleum are alkanes. I'm going to do cracking. Cracking, what are the conditions? In presence of aluminum oxide catalyst and 400 to 700 degrees centigrade, this produces ethene. Now how do I change ethene to ethanol? By addition of water. What are the conditions? Phosphoric acid catalyst and 300 degree centigrade. This produces ethanol. Okay? Methanol is oxidized by atmospheric oxygen. This reaction is catalyzed by platinum. The products of this reaction include a carboxylic acid. So if I'm starting with methanol, so this is methanol. Methanol is something that has 1 carbon and an OH. So this is methanol. Remember when we were talking about oxidation of alcohols, we said if I oxidize an alcohol, I should end up with the corresponding acid. So if I'm oxidizing methanol, I should end up with methanoic acid. Now how do we draw methanoic acid? Meth is 1 carbon. Oic acid means double bond O, single bond OH, and then it is still missing 1 bond, so I put a hydrogen. So this is the structure of methanoic acid. Okay, deduce the name of the ester. Remember how to make esters? We said to make esters, we start with acid and alcohol. So here he's saying I want an ester between methanol and the carboxylic acid that we just talked about, which was methanoic acid. So if I have, this is methanol and I want to react it with methanoic acid, we said how do we draw the ester? We draw the acid first but skipping the OH, and then instead of the OH of the acid I put the O and the rest of the alcohol. So this I remove an OH from the acid and an H from the alcohol. So this is my product. Now what would be the name of this? We said when we draw, we start with the acid, but when we name, we start with the name of the alcohol. Which alcohol did we use? Methanol. Then it is methyl, and the acid was methanoic, then that will be methanoate. So the name is methyl methanoate. Okay? Alkenes can be oxidized to carboxylic acids. Now, this is a reaction that we did not do. We did not do this in the syllabus. But he's explaining what it is. He's saying propene, for example, so this is propene, would produce ethanoic acid and methanoic acid. That means that the alkene breaks up at the double bond to give an acid on both sides. So that is the reaction. He's explaining it. So he's saying deduce the formula of the alkene, which would form the following carboxylic acids when oxidized. So, do you understand the idea? I have an alkene with a total number of carbons and it has a double bond. Now, when we oxidize it, the double bond breaks and you have acid on this side and acid on that side. That means if I want ethanoic and propanoic, then I should have a double bond on one side, F, 2 carbons, and on the other side, prop, 3 carbons. So that would be the alkene. If broken, will give me the required acids that he's talking about. Okay, what if I want something that when I break the double bond, I get only ethanoic acid? That must mean that the double bond is in the middle, and on both sides of the double bond, you have only 2 carbons in order to form ethanoic acid on both sides. Do you get the idea? Okay. So, alcohols can be oxidized to carboxylic acids by heating with acidic potassium manganate. Draw the formula of the carboxylic acid formed by oxidation of prop-1-ol. We said oxidation of an alcohol produces the corresponding acid. So if I'm trying to oxidize propanol, which has how many carbons? Prop is 3. Then I will end up with an acid that has also 3 carbons. So this is propanoic acid. Describe how ethanol could be oxidized to ethanoic acid by fermentation. You should realize that oxidation, we said, either by permanganate and acid or by bacteria in water at room temperature. So when we add bacteria to ethanol, it also oxidizes it to acid. Butanol can be oxidized to a carboxylic acid by heating with acidified potassium manganate. Again, we're trying to oxidize what? Butanol. Then I should end up with the corresponding carboxylic acid, which would be butanoic acid. Now, how do I draw butanoic acid? But has how many carbons? 4. And oic acid means double bond O, single bond OH on the last carbon. The acid has to be on the last carbon because it needs to have only one more bond, because the C double bond O, single bond OH is already 3 bonds on the carbon. So the acid part cannot be inside a molecule. Okay, butanol reacts with ethanoic acid to form an ester. Again, name this ester. We said when we name the ester, we start with the name of the alcohol. Which alcohol does he want to react? Butanol. That means I want butyl. Now, it's reacting with ethanoic, then the ester should be ethanoate. So, when we name it, we start with the name of the alcohol. But then he says I should draw. And we said when we draw, we start with the acid. So, he wants to start with ethanoic acid. That means 2 carbons and then the acid part. That's ethanoic. And then, O what? Butanol, that means I'm going to have 4 carbons. Remember that when we have the acid, I remove from it the OH. And when I have the alcohol, I remove an H and I put it instead of the OH of the acid. So this is butyl ethanoate. Deduce the name of the ester formed from methanoic acid and butanol. Again, how do we name it? Start with the alcohol. The alcohol is butanol, so you want butyl. The acid is methanoic. That means it is methanoate. Okay. Again, we have this acid and this alcohol, and he wants you to deduce the structural formula of the ester. Again, we said, how do we draw esters? We draw the acid, but remove the OH. And then we get the alcohol, remove the H and put the rest. So that would be the methyl butanoate. Okay, again, propanol and ethanoic acid. What would be its name? It will be propyl ethanoate. How do I draw propyl ethanoate? You draw the ethanoic acid first, and then the rest of the molecule is the propyl part. Okay, Give the structural formula of the ester, ethyl ethanoate. Again, ethanoate means it is ethanoic acid. Ethyl means it was ethanol added to ethanoic acid. So that is the ester. Getting better in drawing the ester, you should be able to draw esters. Explain the term monomer. We said in polymerization, the monomer is the small molecule that can be joined together to form a long chain. Now, what is condensation? Polymerization. Remember, polymerization was joining small molecules, but in condensation, it is joining of small molecules that have active group on both ends. We said something that has two acids on both ends or two alcohols on both ends by the removal of small molecules such as water. Explain the term polymerize. We said, what does polymerize mean? Joining many small molecules together to form a long chain. Please study these definitions and make sure that you are able to explain it properly. Okay, there are two types of polymerization. Give their names and explain the differences, and he gives you 4 marks. So you should put all the differences. So we said we have addition and condensation. And we said addition is made from monomers that are unsaturated. They have C double bond C, and the polymer is the only product. In condensation, it is formed by joining monomers that have functional groups on both ends, and this is with the removal of small molecules. So in the end, I get the polymer plus something like water. Okay? Plastics are polymers. They are formed from their monomers by polymerization. 2 methods for disposal are burning and recycling, and he wants you to give 1 advantage and 1 disadvantage of each method. So, advantage of burning or disadvantage of burning, what would be that? Of course, if you burn the polymers that are disposed of, then we prevent accumulation of waste. But the disadvantage is, we said, when we burn polymers, this produces toxic gases. What if I recycle these polymers? Well, the advantage would be I save energy because I don't need to remake more and more polymers. But the disadvantage would be this will also be expensive, because usually recycling these things or reshaping them into different forms and so on requires the use of energy and so on. So this could be expensive. Draw the structure of the polymer formed from propene. Again, when we draw addition polymers, we said we draw this is the monomer. This is what we're starting with. And we said we're going to start with many, many, many of these. Now, how do I draw the polymer? We said I look at the 2 carbons that have the double bond, and I copy them with a single bond so that I have a bond going to something again before it or something after it. And I do that between bracket and right end to indicate that this part is repeated many, many times. Now I look at each carbon and I see what was it bonded to at the beginning. So that first carbon was bonded to a hydrogen and a hydrogen. So we draw a hydrogen and a hydrogen. The other carbon was bonded to what? 1 bond going to hydrogen, 1 bond going to a C that was attached to 3 carbons. So that is a C attached to 3 carbons. So that is my polymer. Okay. Now, polydichloroethene is used to package food. Draw its structure. The structural formula of dichloroethene is shown. We said if I say polydichloroethene, that means the polymer of dichloroethene. So he already gives you the structure of dichloroethene. That's that compound that is drawn, and he wants you to draw the polymer. Again, how do I draw the polymer? The 2 carbons with a single bond, bond from here and bond from here, brackets and end. And then you look at each carbon bonded to what? The first carbon is bonded to 2 hydrogens, draw 2 hydrogens. The second carbon is bonded to 2 chlorines, then you put 2 chlorines. So that is my polymer. Easy enough? Okay. Alkenes polymerize to form addition polymers. Draw the structural formula of polycyanoethene, and he gives you the structure of cyanoethene. So basically he's telling you to draw the polymer of this in exactly the same way. Instead of a double bond, we have a single bond, bond from here, bracket and end. And then The first carbon is bonded to 2 hydrogens, the second carbon is bonded to a hydrogen, and the CN, you copy it exactly as it is. Okay. Here in this question, he does the opposite. He gives you the polymer. So he's giving you the structure of the polymer. And he's saying, deduce the structural formula of the monomer. So that means that I have to do the opposite of what we did in the other one. We remove the bonds on both sides and we put a double bond in the middle. But notice that in this compound we have not just one repeat unit, we have 2 repeat units. So you're looking at which part is repeated. Well, the part that is repeated is the CH2, CH, OO, C, CH3. So that is 1 repeat unit. He's repeating it again. I don't care about the second repeat unit. I am looking at just 1 repeat. So I look at that first part, CH2 bond, CH, OOC, CH3. I remove the bonds on both ends of the carbons and I put a double bond instead of it. So this is my monomer. And you copy it exactly as it is so that you do not make any mistakes. So he wrote OOC, CH3. You copy it just as it is. You don't know what that is, but just copy it as it is. Okay? Now here also he gives me the polymer and he wants the monomer. So again, we remove the bonds on both sides and we put a double bond in the middle and copy everything exactly as it is. Okay, deduce the formula of the monomer of this one in exactly the same way. Remove the bonds on either sides and put a double bond in the middle and then copy everything as it is. Okay, the structure formula of the polymer polychloroethene is given. The polymer is also known as PVC. A major use of PVC is insulation of electric cables. Now, he already tells me that PVC is a poor conductor of electricity, so just another property which makes it suitable for this use. Now, this polymer that he draws a part of, we use it as insulation. Why do you think we use it as insulation? That means we use it to cover electric wires. When we talk about electric wires, we will say that electric wires are made of copper in the middle and they're covered with plastic, which is a polymer. Why do you think it is covered, aside from the fact that it's a poor conductor of electricity, in that it does not corrode or it is unreactive, it will not react with water or oxygen in the air and things. Okay, the other question says one way of disposing of waste PVC is by burning it. So this is burning of a polymer. This method has a disadvantage that poisonous gases are formed. Now suggest 2 poisonous gases which could be formed by the combustion of this polymer. Remember that when we burn any organic compound, which poisonous gas is formed? We said incomplete combustion of an organic compound forms carbon monoxide. But then he's saying, I want another poisonous gas. So what is the other poisonous gas that you think would be formed? Is chlorine. Okay. Deduce the structural formula of the polymer polyphenylethene from the formula of its monomer. So he's giving me the monomer and I want the polymer. Again, in exactly the same way. Remove the double bond, put it as a single, bond from here, and this is repeated n times, and then just copy everything else as it is. So that is the polymer. Okay. What is the scientific term used to describe polymers which do not break down in landfill sites? Remember we said polymers, when we dispose of them, they do not break down in landfill sites. They're not broken down by bacteria. What was the term to signify that they're not broken down by bacteria? The fact that they are non-biodegradable. We said polymers are non-biodegradable. That means they're not broken down by bacteria, so they accumulate in dump sites. Then he gives me here a polymer and he says deduce the monomer. Again, if I have the polymer and I want the monomer, we said just remove these bonds and on either ends and put a double bond in the middle, and that is my monomer. Copy everything as it is. The C6H5, you copy it as it is. Don't sit down and draw out 6 carbons or any of these things, because that's something that we haven't studied. Okay, again, this is my monomer and I want the polymer, so again, this is the same thing. Okay, Again, this is another monomer, so this is enough practice. But remember here, now he's asking something else. He's saying include 3 monomer units. That what we have been drawing in the previous question, for example, we drew only 1 repeat unit or 1 monomer unit. Now he wants 3 of them, so that means you draw it as if you're drawing 1, and then you repeat it 3 times in exactly the same way. So that is the polymer with the 3 monomer units, or we call them 3 repeat units. Okay, give the structural formula of a polymer which is formed from 2 different monomers. Remember that we were talking about polymers and we said there are 2 types of polymers. All the polymers that we have discussed so far are addition polymers. But then there was something else called condensation polymer, and condensation polymers were made from 2 different monomers that had active groups on both ends. So here, when he's not specifying, remember that we had 2 types of condensation polymers. We had polyester and polyamide. Here he's not specifying any one of them, so you can draw any one of them. So this is which one? This is the polyester or the polyamide? This is the polyamide, the one that has N nitrogen. It is a polyamide or nylon. So this is one type. Or you could draw the polyester, in which instead of the NHs on the other carbon, on the other box, you can have only oxygens. Okay, draw the structure of a synthetic polyester. Again, how do you draw polyester? This is a polyester. Please sit down and practice it. All these condensation polymers start with C double bond O box C double bond O. If I'm talking about a polyester, it is C double bond O box C double bond O and then O box O. If it is a polyamide, C double bond O, C double bond box, C double bond O, NH box NH. You have to memorize these. So if he just says draw polyester or draw terylene, then that's the polyester that you draw. If he says draw polyamide or draw nylon, then that's the one with the nitrogen. What is meant by the term carbohydrate? Now you should know that carbohydrates are organic compounds made of carbon, hydrogen, and oxygen, in which the hydrogen and oxygen occur in a ratio of 2 to 1. Because you have 2 marks, you have to give these 2 points. That first of all, they're made of carbon, hydrogen, and oxygen, and that the hydrogen and oxygen occur in a ratio of 2 to 1. That's the definition of carbohydrate. Now, the formula of glucose can be represented as this. He says, draw the structural formula of a complex carbohydrate. Remember that complex carbohydrates or starch are drawn like this. If he says draw starch or draw complex carbohydrate, that is what you draw. O box O box O. And this is repeated n times. Okay, describe how you could decide from its molecular formula whether a compound is a carbohydrate. Again, we said if it's a carbohydrate, then it is made of carbon, hydrogen, and oxygen, first of all, and then the hydrogen and oxygen should occur in a ratio of 2 to 1. Then he says plants can change the sugar glucose into starch, which is a more complex carbohydrate. What type of reaction is this? Remember that when we talked about it, making glucose into starch, that is condensation reaction. Now breaking the starch into glucose, that was hydration. So here he's starting with glucose and he's changing it into starch. This is a condensation reaction, and that's why we call it condensation polymerization. Okay, what is the product of hydrolysis? Hydrolysis means if I break it up. Now if I break up proteins, it will form what it was made of originally, and you should know that proteins were made of amino acids originally. So when I break up the proteins, it will give amino acids. Now fats, we said, were made up of originally of what? They were made of fatty acids and glycerol. So hydrolysis means you're going to break it up, then it will give you the fatty acids and glycerol. What are complex carbohydrates made of? They are made of glucose. So when you do hydrolysis of the complex carbohydrate, you end up with glucose. Okay, and then he's asking what type of synthetic polymer contains the same linkage as these things. Now remember that fats, proteins, and carbohydrates are regarded as natural polymers. Now fats are polyesters. So the normal synthetic polymer that has this kind of linkage is terylene. Remember, polyesters. Natural polyesters are fats. Synthetic polyester is terylene. Now proteins. Proteins are natural what? We said proteins are polyamides. So which is synthetic polymer is also a polyamide? We said that is nylon. What is the name of linkage in proteins? You should remember that proteins have an amide linkage. The C double bond O, NH, this is an amide linkage. Name a reagent which can be used to hydrolyze proteins. Remember we said hydrolyze proteins means break it up. If I want to break it up, I heat with hydrochloric acid or any acid. What type of compound is formed by the hydrolysis of proteins? When we break up proteins, it gives amino acids. Okay, what are enzymes? You should realize enzymes are biological catalysts, protein in nature that speed up reactions in living cells. We talked about this when we were talking about rates of reactions. Now, name another substance which can hydrolyze proteins. Well, to break proteins, we said we heat it with hydrochloric acid. What type of compound are the monomers formed by hydrolysis of proteins? Again, when we break up proteins, they form amino acids. Now, which technique could be used to identify the monomers in the mixture? To identify amino acids, what did we use to identify amino acids and know which type of amino acids we have and so on? This is something from the first few chapters. We used something called chromatography. Do you remember that? So we use chromatography to distinguish between different molecules. Proteins contain the amide linkage. So proteins are the natural polyamides. And he's saying name a synthetic macromolecule that contains the same linkage. So I want the synthetic polyamide. The synthetic polyamide is nylon. Do we remember that? Okay. A condensation polymer can be made from these monomers. So he gives me monomers and he tells me to join them. And remember, how did we join these things? We remove the OH from the acid and H from the next one. So these are the molecules when you draw them out. The COOH is actually C double bond OOH. The NH2 is actually like this. So this is the formula drawn out. Now when we want to join them, we said what do? We remove the OH from the acid and the H from the next one. OH from the acid and the H from the next one. And we join them. So that is the polymer. Can you see what I did? Okay. Again, he gives me two monomers and he says join them. Well, it's exactly the same thing. Remove OH from the carbon and H from the nitrogen. Okay. Again, here he has protein. He said it is protein. So insert the linkage. Remember that we said proteins are polyamides. They have an amide linkage. And we said the amide linkage is the C double bond O and H. So this is what you need to put in. Which group of naturally occurring compounds contains the ester linkage? Again, what has ester linkage? Fats. Draw the structure of these. So you're supposed to join them together. Again, we said we remove the OH from the acids and H from the next one. So this is the molecule that you should end with. Okay. This question says unsaturated fats and oils contain at least one carbon-to-carbon double bond. These double bonds react with bromine water, which changes color from orange to colorless. Plan an experiment that could be carried out to compare samples of sunflower oil. So these are different types of fats. And he wants to find out which of these contains the largest number of double bonds between carbons. Okay. We said if I have a double bond, if I have more double bonds between the carbons, then I should need more bromine to react with the double bonds. Okay, and we said when the bromine reacts, then it changes from orange to colorless. But once we have finished all the double bonds and I add any more bromine, then it should remain orange. That's the basic idea. So this is what we should do. Put 10 centimeter cubed of the first type of oil, sunflower oil, in a test tube. Add 10 centimeter cubes of ethanol using measuring cylinder to dissolve it, because we need to dissolve the oil in something. So oil does not dissolve in water, it dissolves in organic solvents, which is ethanol. And then I start adding drop by drop using a dropper, and I count the number of drops needed for the orange color to remain. Do you understand that? So I add a drop of bromine, it will react and it becomes colorless. I add some more, it reacts and becomes colorless. So it's as if we're doing a mini titration. Okay, and the first drop that remains as an orange color, then I have stopped and I count the number of drops, and I repeat using the same amount of the other oils. The one that needs more drops is the one that has more double bond. Were you able to think of that? Okay, some of the fractions obtained from petroleum are given, and he's saying state a use, and you need to memorize the uses of these things. Butane, we said we use for road making. What do we use lubricating fraction for? Waxes and policies. Paraffin, fuel for jets. Gasoline, fuel for cars. Don't just say for jets, for cars. No, you have to say it is a fuel for jets. It's a fuel for cars. Okay, now the multiple choice question. So he has this and he says, what are fractions x, y, and z? Remember, you are required to know the order in which these fractions are removed. So he's asking for something in between gasoline and diesel oil. You should realize that that is paraffin. And then Z, the last one, is butane. So your answer must be D. Okay, here structures of 3 compounds. Why do these substances all belong to the same homologous series? Well, I look at them and I say, okay, which homologous series do they belong to? They all have double bonds, so they are all alkenes. So why did we say they're all alkenes? Because they all have the same functional group. Okay, which of the following is an alkene? How will I know? Well, he already told me that we already know that the general formula of alkenes indicates that the number of hydrogens should be twice the number of carbons. So should I choose A? No. An alkene has to have double bond between 2 carbons. If I have just 1 carbon, I cannot have 2 double bond. So CH2 is not an alkene in the first place. I have to have at least 2 carbons to have a double bond between them. So my answer is C. Okay, where the hydrogen is twice the carbon. Which structure is incorrect? Again, I'm going to remind you that each carbon must have only a total of 4 bonds coming out of it. So each carbon must have 4 lines coming out of it. Any more would be wrong. So C, the carbons have too many bonds. Each carbon has 1, 2, 3, 4, 5 bonds. That's not right. We must have only 4. Increasing the number of atoms in one molecule of a hydrocarbon increases the amount of energy released when it burns. So he's saying which of these will give least energy and which of these will give more energy. And he's telling me that the one with more number of carbons gives more energy. Well, let's see. He has methane, ethane, and ethene. So ethene is what? So ethene is this with a double bond. So what is the number of atoms? He's looking for number of atoms. How many atoms do I have in ethene? Well, I have 2 carbons and 4 hydrogens, so I have a total of 6 atoms. Okay, what about ethane? Ethane is this. So this has 2 carbons and 6, so this is 8. So this is more. What about methane? Methane has only 1 carbon and 4, so that is 5 atoms. So the one with less number of carbons is the one that gives less energy. So methane is the least one, and ethane is the one with the more number of atoms. Remember, he's saying number of atoms, not number of carbons. Okay? Okay, which molecule shows the structure of hexene? Even if you don't know what hex means, all of these are 6 carbons. So that's not the difference between them. He's asking for which one is ene. Of course, the one that is ene is the one that has a double bond. Okay, which statement about alkenes is not correct? So which statement about alkenes is not correct? Which one did you choose? Not correct. Remember again, sometimes these questions say which statement is correct or which statement is not correct. So he's saying which one is not correct. You should realize, okay, A says the functional group is C double bond C. Yes, an alkene should have C double bond C. Okay, the next one says the structural difference between one member and the next is CH3. Well, let's check. If this is ethene, ethene is C2H4. The next one is propene. Propene is C3H6. Now, is the difference between these two one carbon and 3 hydrogens? No, actually it is 1 carbon and 2 hydrogens. So actually the structural difference between one member and the next should be CH2, not CH3. So this is the wrong statement. So this is my answer. C says the form a homologous series. Yes, all alkenes are one homologous series. And D says the turn aqueous bromine from bromine to colorless, from brown to colorless. Yes, of course, this is the test for alkenes. So B is the one that is not correct. Okay, this diagram shows 3 repeat units of a polymer. Which alkene monomer was used? Remember, again, if you look at something that has many repeat units, you only look at one of the repeat units. And you remove the bonds on either sides of the carbon and you put a double bond in the middle. So if you do that, which one do you think is the answer? So this is my monomer that I need to look at. I remove the bonds on either side and I put a double bond. So obviously this should be C. Whether the chlorine is up or down doesn't make a difference. Okay? Okay, ethanol can be manufactured from substance X. So he wants something plus steam to give ethanol. Remember, to make ethanol, I add steam to what? I add steam to ethene. Okay, petroleum is a mixture of hydrocarbons which can be separated into fractions using fractional distillation. Which fraction is used as fuel in jet engines? Remember, which one is used as fuel in jet engines? It is kerosene, or what we call paraffin. So remember that kerosene is the same as paraffin and it is used as fuel in jet engines. Which structure is correctly named? So which one has the correct name on it? Now let's look at A. He's saying A is ethanoic acid. Is eth 3 carbons? No, eth is 2 carbons and this one has 3, so that's wrong. Well, B he's saying is ethene. Is that ene? No, ene should have a double bond. What about C? C he says is ethanol, eth 2 carbons, all yani OH, so that means this is the correct one. What's wrong with D? D says propane, but actually it has a double bond, so that should be propene. Okay, which properties of the different compounds in petroleum enable its separation to fractions? We said when we separate petroleum into fractions, we use fractional distillation because they have different what? Because they have different boiling points. So I must choose one. But then I need also the chain length, because we said the chain length determines the boiling point. If I have 1 carbon, 2 carbons, 3 carbons, then the boiling point is low. If I have many carbons, then the boiling point is high. Okay? Bitumen is a substance obtained from the fractional distillation of petroleum. Which row describes its boiling point and the size of its molecules? Remember, in the fractionating column, where is bitumen? It's at the bottom. And we said at the bottom, the things at the bottom have high boiling point or low boiling point? We said high. And we said when something has a high boiling point, will it have a large molecule or a small molecule? It's a large molecule. So bitumen is at the bottom, it has high boiling point, and it is large molecules. The diagram shows some properties of 2 organic compounds X and Y. What are X and Y? He said X is something that reacts with bromine and forms polymer. So X is ethene or ethene. Remember, the one that forms polymer is the ene. So my answer is C or D. Y, he says Y is used as a fuel and used as a solvent. So that should be ethanol. Okay? A chemist carried out a cracking reaction on a hydrocarbon. The chemist then wrote the following statements in his notebook. Which statements are correct? So he's saying a molecule of X has 7 carbons. Well, let's see. X should have the total number of carbons that are after the arrow. So how many carbons do we have after the arrow? 4 plus 3, that's 7. So 1 is correct, right? Y is unsaturated. Where is Y? What do we mean by unsaturated? We said unsaturated means has double bond. Does Y have a double bond? No. Z will decolorize bromine water. Which compounds decolorize bromine water? Alkenes. Is Z an alkene? Yes. So actually it is 1 and 3, so my answer is C. A hydrocarbon X is cracked to make Y and hydrogen. Compound Z is formed by addition of polymerization of Y. Okay, let's see. A hydrocarbon X is cracked to make Y. We said what kind of compounds do cracking? Cracking are alkanes. Okay, so we have alkanes. X could be an alkane like this. Y, when we crack it, it gives Y, which has a double bond. And when we do polymerization of Y, we should end up with Z. So the answer is C. Okay. Which row is correct for ethanol? We said, will ethanol burn or not? Yes. Almost all organic compounds are flammable and will burn. Can I make ethanol by fermentation? Yes. So my answer is A. The table shows the composition of 4 different types of petroleum, and he's saying which type of petroleum is best for motor vehicle industry. Well, the motor vehicle industry wants the fuel that is used for cars. Which of these is a fuel used for cars? Gasoline is used as a fuel for cars. So the best of these would be the one that has the bigger percentage of gasoline. Which of these has a bigger percentage of gasoline? The North Sea, so that's my answer. Okay. Which products are obtained by cracking of an alkane? Remember we said when we do cracking, either we have alkene plus alkane or we have alkene plus hydrogen. We never get water from cracking. Okay. What is petroleum? You should realize that petroleum is a mixture of hydrocarbons. The diagram shows the first 4 members of a homologous series. What is the difference in the formula between one member and the next? Remember that when we look at it, what are we adding in each time? We're adding 1 carbon and 2 hydrogens, 1 carbon and 2 hydrogens, so the difference between them is a CH2. The diagram shows part of a polymer. Which compound is used as a monomer? So again, we look at this compound. Where is the monomer? Well, it is this part that is repeated many, many times. Remove the bonds on either sides and put a double bond. So actually that is ethene. So that is the one that was a monomer for this polymer. The table shows the composition of natural gas. Remember, we said, what is the main constituent of natural gas? It's methane. The apparatus shown may be used to study the products of fermentation. What is the purpose of the aqueous calcium hydroxide? Remember, maybe we haven't mentioned it before, but actually aqueous calcium hydroxide is what we call lime water. So the lime water is to show that carbon dioxide is produced. When the carbon dioxide comes out, it causes the lime water or calcium hydroxide to become milky. Which pair of substances could react to give this ester? Well, let us look at this ester. The first part here was the acid, and the other part, which is the CH3 on the end, was from the alcohol. So the acid obviously has 3 carbons, so I want an acid that has 3 carbons. So which acid has 3 carbons? Propanoic acid. And the rest of it was from the alcohol, and the alcohol has 1 carbon, so that is methanol. Do you understand how to get it? Okay, in the reaction pathway below, an alkane is converted into a carboxylic acid through several stages. Which processes occur at stage 1 and stage 3? Okay, let's take a look at stage 1. He has something with large number of carbons and he breaks it up to form ethene, and we said this break up of long chain hydrocarbons into shorter chains is called cracking. So my answer is B or C. Okay, where is stage 3? Stage 3 is changing ethanol to ethanoic acid. So that means I'm changing an alcohol to an acid. This kind of reaction was called oxidation. So my answer is C. Okay, he gives me a compound that has double bonds, and he says which product is formed when bromine reacts with this. We should know that when bromine reacts with a double bond, what happens is it opens the double bond and it puts bromine on, 1 bromine on each of the carbons that have the double bond. Here I had 2 double bonds. Can you see where the double bonds are in limonene? I have 2 double bonds, so I'm supposed to open these 2 double bonds and put a bromine on each of the carbons. So that my answer is D. Can you see that it's D? Okay. The structures of some organic molecules are shown. Which structures represent an alkane with 4 carbon atoms? So where is alkane with 4? Alkane means it has only single bonds, so 1 cannot be included. Okay, 1 is not an alkane. Now, which ones have only single bonds and have a total of 4 carbons? So 3, of course, has only 3 carbons, so 3 cannot work. 2 has 4 carbons and 4 has 4 carbons, so it is 2 and 4. Some of the fractions obtained from fractional distillation of petroleum are used as fuels for vehicles. Which 2 fractions are used as fuels for vehicles? Okay, vehicles means any transportation. So he wants something that can be used for fuel for cars or fuel for aircraft bodies. Remember that fuel for cars is gasoline and fuel for aircrafts or jets is kerosene. Burning fossil fuels releases heat. Which substance is not a fossil fuel? Remember, a fossil fuel means a fuel that is obtained from remains of plants and animals, and you should remember which ones are fossil fuel. Coal is a fossil fuel, petroleum is a fossil fuel, natural gas is a fossil fuel, but hydrogen is not. Okay. X, Y, and Z are 3 hydrocarbons. What do compounds X, Y, and Z have in common? They're all alkenes. Is that correct? Yes, they all have double bonds, so they're all alkenes. They're all part of the same homologous series. Yes, if we say they're all alkenes, then they're all part of the same homologous series. They all have the same boiling point? No, we said the boiling point depends on the number of carbons. So the more carbons, the higher the boiling point. So the only ones that are correct are 1 and 2. Okay, what type of compound is X? So he's saying X has single bonds between carbon, single bonds between hydrogen, and it has a bond between carbon and oxygen, and it has a bond between C double bond O, and it has a bond between OH. So something that has double bond O, OH must be something looking like this. So that is an acid. Okay. Which statement about polymers is correct? Okay, nylon contains this linkage. Is that correct or wrong? Yes, actually that is my correct. If I look at nylon, this is nylon. It has this kind of linkage. Yes, so my answer is A. So what about B? B, he says nylon is a polyester. No, we said nylon is a polyamide. Propane can be polymerized by addition, polymerization. No, propane is not something that has a double bond, so I cannot use it to make polymer. Now, the linkage in terylene contains a carbon-carbon double bond. No, there is no carbon-carbon double bond in terylene. So my answer is A. The diagram shows a reaction sequence. Which row names the processes X, Y, and Z? Again, from alkane to alkene, we do cracking. So X is cracking, A or B. And then from ethene to ethanol, well, how do I make ethanol from ethene? By adding water, so that is hydration. Check again, ethanol to carbon dioxide and water, that is called combustion. So remember these reactions. Which pair of compounds can be used to prepare this? Again, when he writes this, you divide it into 2. The first part, including the COO, that was the acid. So if it has 3 carbons, that means I want propanoic acid. Now the rest of the carbons was from the alcohol. So that is an alcohol with 2 carbons. So I need propanoic acid and ethanol to make this ester. Okay, the structure of a synthetic polymer is shown. The structure shows that it is a what? A polyamide or a polyester? Remember, the one that has N nitrogen is polyamide. So my answer is A or B. Now it is formed by what kind of polymerization? Remember that these kinds of polymers are formed by condensation polymerization. Okay, that was the last question. I hope that you were able to get as many of them as possible.